Welcome to HydraMaster's CDS xDrive service training video series. It's part 1. Part 1, we're going to cover the Ford Transit, what it is that makes the Ford Transit such a good fit for the xDrive and how we integrate into it. Talk a little bit about the model years that we can install in, what the recommended models are. Talk about Ford's position on the van being used as a stationary power source. So as the application of the CDS xDrive requires that the van be stationary, Ford actually has a position on how that is acceptable to them as being used as a power source. They provide a throttle control system that's integrated into the vehicle, so we'll take a look at that. And then we'll also look at the other modifications that we have to do in order to install the xDrive into the van. We have to change a few little things, a few hoses and whatnot on the van itself. So the Ford Transit came out in 2015, and soon thereafter we began looking at it to integrate the xDrive into. Even though the van came out in 2015, the first couple of model years did not have a good throttle system on them, did not come with the integrated throttle system, so they weren't really compatible with the xDrive. But then in 2017, Ford made their integrated throttle system standard on all models, so that really helped. So between 2017 and 2019, the Ford Transit was available with a 3.7 liter naturally aspirated engine. Also was available in a 3.5 turbo, which they call their EcoBoost, and a 3.2 liter diesel. The EcoBoost and the diesel we are not able to use for this CDS xDrive. So the 3.7 liter engine, 2017-2019 is the engine we use. The van itself comes in 3 different roof heights. Comes the low, medium, and high. We can do any one of those. With just a little caveat, the low roof van may require some modifications to the tank lid, because the tank lid usually hinges side to side, but with the low roof, we have to actually hinge it front to back. So might be a few little changes in order to do that. The weight rating, as designated by the model, the T250 is the 3/4 ton, and the T350 is the 1 ton version. So either one of those works well. And then the wheelbase comes in regular, long, and extended. We usually use the long wheelbase, 148-inch wheelbase, which gives you plenty of extra space in the back. In 2020, Ford made a change to their powertrain. The 3.7 liter engine went away, and they replaced it with a 3.5 liter, call it a PDFI engine, or port and direct fuel injection engine. So it's actually a dual injection system, a fuel system. Works very well. The engine runs extremely smooth, noticeably different than the previous model year. So the 3.5 liter engine is the one that we can adapt for CDS xDrive. They still have the EcoBoost, which is also a 3.5, and a new diesel. So we still can't do the EcoBoost or the diesel. Same roof heights, low, medium, high. Same issue with the low one. Might have to change the lid a little bit. The T250 and T350 are still the preferred GVW ratings. They did add something nice in 2020. They added an option for a heavy-duty front axle. They call it their 41E option. Adds 500 pounds to the front axle rating. Doesn't actually change the GVWR of the entire vehicle. It just shifts some of that weight rating from the back to the front. That also works well for us. It is a factory option, though. You will have to order it from the factory. Same wheelbases, regular, long, extended. Another option that they've started doing in 2020 also is their all-wheel drive, and it is available on the 3.5 liter PDFI engine. We have not done one, but from everything that we can tell, we should be able to do that. And if somebody wanted to try that, we could certainly try that. Going on with the Ford Transit. It's a little bit about the integrated throttle control that the Ford Transit has available. It is available on 2017 and newer vans. Prior to that, it was an option. You had to order, but 2017 they made it standard. So Ford calls it their Ford Stationary Elevated Idle Control, or SEIC for short. The xDrive requires approximately 20 horsepower to operate correctly, and so to ensure that the power is available when we need it, the engine RPM needs to be elevated to about 2,000 RPM. So to do that, we use the Ford's Elevated Idle Control, or SEIC. The SEIC has some what they call enable and disable conditions, and we'll go over that. There are certain things that have to happen before the idle can be elevated on the truck, and then there are some conditions that will actually turn off the elevated idle. The SEIC wiring access point is inside the engine compartment. We'll take a look at how we access that. And then when it is, Ford recommends when the vehicle is used as a stationary power source, that what they call their severe duty maintenance schedule be utilized. And that's really just comes down to more frequent oil changes, but again, we'll take a look at that. The SEIC wiring can actually be accessed. It's in the wiring harness, the Ford wiring harness, just behind the coolant reservoir tank on the driver's side, just inside the engine compartment. And it is in that next image you can see it's actually part of the Ford harness. You have to actually pull a little bit of the harness back, and then the wires are accessible. So it is a completely Ford authorized, Ford provided throttle control system. So this is what the Ford says about their elevated idle control system. This is from their what they call their bodybuilder's layout book. This is a book that they put out every year that instructs aftermarket or OEM manufacturers on how to modify their vehicles. So this is what they say about the SEIC strategy. They say, one, it provides elevated engine speeds to drive auxiliary commercial equipment, and has a whole list of things, and one of them is generators. So that's basically what we're doing. It also says that that the PTO usage may require using Ford's severe duty maintenance schedules, and then severe duty is defined as extended idling. So that's pretty much, again, what we are using this for. So the operation of the SEIC in 2017 to 2019, the way the xDrive communicates with the Ford throttle control system required one resistor, one relay, 2 signal wires, and then 1 power wire. On the xDrive console, that was controlled through fuse number 1, which is the power that goes and tells the SEIC that you want to operate, CR1 or relay number 1, which was actually the command to operate the SEIC. And then there was another fuse number 2, request that had to be made. That's what they call it, a request to start operating. And then the ground for the relay was actually also through the engine control module. In 2020, though, they changed a little bit and actually made it quite a bit simpler. So in 2020, now you still need the resistor. That's what sets the engine speed. But you only need one signal to the SEIC. You just tell it to operate, and it starts to operate. So now fuse 1 is really the only power source from the xDrive required to operate the SEIC. The CR1 relay and then the power from fuse 2 are no longer necessary. So that's a change to the wiring harness in 2020. So here's the wire colors and wire pin numbers in the 2017-2019 SEIC plug. So this is the plug that we, when we install the unit, we actually connect this plug to those wires that are in the Ford wiring harness, and then our harness connects to it from the xDrive. Pin number 1, actually pin number 5. So the our orange and white wire went to Ford's blue wire. You can see that the SEIC box there on the bottom, the image on the right. Our orange and white, so our wire number 60 connected to the solid blue SEIC wire, pin number 5 in the plug. Pin number 4, we had a blue and white wire that connected to the blue wire with 2 white stripes from the SEIC. That one is actually a little difficult to find. Finding one wire with 2 stripes is kind of tricky, but it can be done. We'll show you how to do that later. That's pin number 4. The yellow wire from the xDrive harness goes to the green wire. That's pin number 6. And then pin numbers 1 and 3, so on the very bottom of that image, the green and white wire from the SEIC, so the Ford wire, comes out of the engine control module, goes through our plug, goes through the resistor that we have in our harness. It's a 1.1 kilo ohm or 1100 ohm resistor, and then goes right back into the SEIC engine control module on pin number 1. So that's how we set the speed at 2000 RPM. Again, they made it a little bit easier, a little bit simpler on 2020. So now 2 of those wires are actually eliminated. So we only have the one wire, the one orange and white wire number 60 coming in to pin 5, and then the 2 wires coming out and going back in for the resistor, and those are all on the same pins as they were before. So these are the enable and disable conditions. The enable conditions are on the left. So the parking brake, the emergency brake has to be applied, food off, service brake. It's supposed to be foot off, service brake. If you touch the brake pedal, the vehicle has to be in park, foot off the accelerator pedal, so no signal from the accelerator. Vehicle speed has to be 0. The brake lights have to be functional. Haven't actually tried this, but that's what they say. If a brake light goes out or if they're not functional, the elevated idle control will not work. The engine needs to be at base idle, which is around 600 RPM. When the engine first starts, it's up around 900 to 1,000. After a couple minutes and the engine warms up, it comes down to 600. Transmission oil temperature has to be above 20 degrees Fahrenheit. And the engine coolant temperature also has to be above 20 degrees Fahrenheit for the SEIC to operate. So on the right, there are the opposite conditions, I guess you might say, the conditions that disable or will shut off the elevated idle. If the parking brake isn't engaged, idle will not come up, or if it's disengaged while it's operating, it will disengage. If you step on the brake pedal, it'll stop the SEIC. The vehicle is taken out of park. If the accelerator pedal is depressed, vehicle speed is anything other than 0. If the brake light circuit is disconnected, will cause it to stop operating. Transmission oil temperatures over 240. Engine coolant temperatures over 228. That can happen if the fan fuses. So the fuses that operate the 2 electric cooling fans blow, then the engine coolant temperature can get up to that, and it'll drop the SEIC out. And then the catalytic temperature is above around 1400. It doesn't actually say what the temperature is, but we've measured it, and it's around 1400. So some of the other modifications that we have to do to the vehicle itself in order to install the xDrive and have it operate. There's an oil pressure sender on the side of the engine right next to the generator that we have to relocate just because it sticks straight out from the engine, we have to put an elbow on it so it doesn't stick straight out. The engine oil cooler, I'll show you that. Some of the engine coolant hoses, just like any CDS, we tap into the engine coolant hoses. And then there's an electrical wire harness mounting bracket on the frame next to where the generator is mounted that we have to make a slight modification to so that it doesn't run into the generator. So the old pressure sensing unit picture there on the left, you can see the pressure sensor. It's got the cable going to it. The picture is from a 2017 to 2019, and you can see down right next to the engine, right under the pressure sensor, there's a brass elbow, 90-degree elbow. So that's what we did from 2017 to 2019. In 2020, though, they changed the fitting. They actually changed the sensor so that it was no longer a pipe thread. Now it's a straight thread. And so in order for us to make a fitting that would adapt to that straight thread, we actually had to make a fitting. And that's what we have on the right-hand image. Commonly referred to as a banjo fitting. So if you're familiar with hydraulics, it's just a sandwiched 90-degree fitting. The bolt part we actually purchase, but the actual adapter we actually have to manufacture. So that's a custom part starting in 2020. It comes in the kit. The oil cooler is what they call a sandwiched oil cooler. It's between the engine oil adapter and the oil filter in between. And then it has coolant lines coming in and out. The image on the left is the original cooler that comes on the van. And you can see that the coolant lines actually come out and come in to the top of the cooler. Didn't work real well for the placement of a generator, so we actually had to change it. We are still using a Ford oil cooler, same dimensions. It's just off of a different engine. It has the ports, that's the one on the right-hand side, has the ports coming out the side, which is much easier for us to get around the generator when it's in place. So that also comes in the kit. We, just like other CDSs, we have to tap into the coolant system. On 2017-2019, we had to change the radiator to thermostat housing, both oil cooler hoses we needed to replace, part of a heater return hose, and then the hose that went from the engine all the way down to the radiator. So the primary radiator hose had to be replaced. Starting in 2020, though, again, they made some changes when they put the new engine in. They changed some of the coolant hoses around, so it actually made it a little bit easier. Now we just have to replace one of the oil cooler hoses. We tap into the heater return hose, actually just cut it and put a T in. And then the engine to radiator hose, which is the one, again, that all of the CDSs have, we just cut that and put a T in. That's where we access the engine coolant. There is one bracket that has to come off and be modified. And then there is also a modification to the alternator cable. The cable that comes off the back of the alternator, the heavy gauge charging cable, goes down towards the starter motor and then back up to the battery. We had to make a change to that because we really relocate the alternator. We had to get a little bit more length on the 2017 through 2019, which is this picture. We had to actually make a little extension. We made about a 6-inch extension of both the heavy gauge cable and the control cable, which is the small one that has the plug on it. We were able to later on in about the 2019 model, able to actually change the routing of the cable itself to get that extra length, and we stopped using those little patch cables around the 2019 model. But in order to do that, we have to take the cable all the way during the installation process, take it all the way out and reroute it. But that did allow us to not use those little patch cables anymore. The wire harness bracket, there was talking about. This is also, actually, that first image, so you're looking down at the top of the generator, looking past the alternator. On the right-hand side of that image, you can see that block down there that has a couple of pressure hoses or hydraulic lines going to it. That's actually the ABS unit. Right below the ABS unit, and so right next to the generator, is this bracket. In the next image, there are four different Ford electrical harness plugs that are attached to that just keep them from moving around. So the top half of that bracket actually interferes with the generator, so we have to take off the top half of the bracket, and then we just put it back on. You can see in the image there are three of those wire harness clips that are still used in the original positions. So that's the 2017 through 2019. The 2020, it's basically the same thing. They did change the design of the bracket a little bit, but it does the exact same thing. Just looks a little bit different, but we have to do the same thing. We have to modify that. So for 2020, there are basically the same modifications that have to be made. Engine coolant hoses, even though because of the new engine, there's less modification to do with the coolant hoses, which is nice. Oil pressure sensor adapter, that's new. Wire harness bracket is a new bracket. It's modified basically in the same configuration. And then the alternator wire also needs to be modified. It's a little different configuration than the previous model, but it's modified again in the same manner. So just a real quick note about the differences between the standard CDS and the xDrive. What they have in common, and so we won't cover that in this video series, is the high pressure water pump. That's the same pump between the standard CDS and the xDrive. Chemical system is the same. The air to water heat exchanger, so salsa heat exchanger, same configuration. It's a little bit different in where it's mounted, but it's the same configuration. The float switches are the same, water box is the same. Some of the things that are different between the standard CDS and the xDrive are the pump clutch. It's got a different clutch on the pump. Cables, obviously the power cables, the large 1/0 power cables are different. AC motors, motor controllers, line contactors, all of the things that have to do with driving the motors, those are different. Circulation pump, so the xDrive has a little pump that actually forces the water through the heat exchangers and through the xDrive. And then the fuse box, it's got a little fuse box that the standard CDS does not have. So that little circulation pump is made by Bosch. It's an automotive part, actually made for the hybrid vehicle, sometimes the hybrid vehicle, and some of the other vehicles these days, but hybrids in particular. The engine isn't running, but they still want the coolant to be flowing, so they use this little pump. It's 12 volts. They rate it for 100,000 miles, so it's a very good little pump. Operates at 275 degrees, well above the coolant temperature, and in our application it moves about 1.5 gallons. It pushes a fair amount of coolant through the system, and that's actually what makes this work so well. We'll go over the engine coolant and the modifications that we make to the coolant system on both 2017 through 2019. So that's the 3.7 liter engine, and then we'll talk about the new one, the 2020 and the 3.5 liter engine. Starting in this diagram, starting down on the left-hand corner, so this is the radiator hose that comes out of the engine, goes out of the engine into the radiator. This is the same hose on all CDSs, and this is actually the same T that we use in all the CDSs, so we just cut that hose and put the T in place. So that's how we access the coolant. Right next to that T, however, we put that little coolant pump. So we're actually pushing pushing coolant through the system, and it starts right there. So in the xDrive, we're pushing water back through, actually comes through the floor, right behind the passenger seat, comes into the heat exchanger. This is showing the plate style heat exchanger, which is the current version. Some of the older models still had the shell and tube, but it comes in and goes out at the same location. It comes out of the heat exchanger, goes into the motor, comes out of the motor, goes back across to behind the driver's seat, goes through the floor, up to the front of the engine, into the generator. Comes out of the generator, goes up to a Y fitting, which was actually the original. It was part of the van. We just used it. We put this T into the engine coolant reservoir hose and relocated. That's where the coolant hose used to go, is to that Y. We put it in line with the heater core instead. And then from there, the coolant returned back to the engine. It had this other loop in it, which we had to make some modifications to in order to make room in the engine compartment. The hose that went from the bottom of the radiator up to the thermostat housing, we had to completely replace that. There was this T in here, it's a plastic T, that they used to redirect coolant down to the oil cooler and then back up and back into the main stream. We had to move it from this location, so we put in a little tube, moved that T up to the top where we could make room for it. And then there's another hose that went to the power steering cooler, which we also had to replace. So those are the modifications that we had to make for the 3.7 liter engine. Starting in 2020, it got a little simpler. The 3.5 liter engine had a different routing. It was the same. So if we start again at the engine, come out of the engine to radiator hose, we put the T in, the pumps in the same location. Hoses go up again through the floor behind the passenger seat to the heat exchanger, out of the heat exchanger into the motor, out of the motor back across to the driver's side, and then back up to the generator. But here now, it just comes out of the generator, goes into kind of the same as it was before. There's a Y fitting that the coolant reservoir went into. We move that where the coolant reservoir comes in to the heater core line, and then we use that open port on that Y for the generator, engine coolant coming from the generator to come back into the engine. The only other hose that we have to replace is one of the hoses that comes from the oil cooler back up into the main flow. They changed the transmission oil cooler. They actually added a transmission oil cooler. It is actually a new transmission behind the 3.5. It's now a 10-speed transmission, but it has a cooler on the side of it. So they route water from the engine through that transmission cooler and then back to the oil cooler and then back to the engine. So they changed the configuration, made it a little bit easier for us. So that's the 3.5 liter engine in the 2020 Transit.